to 8. We want to get this started over by 8:30. It seems like there are drinks waiting for us at the bar. That's where the community work actually happens. Not gonna lie. All right, so let's take this a little bit further. So I'm going to go back to the slides for a little bit. We'll go back to demos in a little bit too. Kind of bounce back and forth. Our code. So our code in SQL Server. You saw the sample hello world. Just so you can see, this is a basic template of, okay, I'm going to have my R script. I will put my R script in a variable in SQL and lay it out. R is not space sensitive or tab sensitive. It is a lot more friendly. Python, it's got its quirks. It's not really that bad. More SQL. Here's my query from my database. So that flat table you saw there, select star from sensors will give me that. Then you can see here, now my SP execute external SQL script is a little more readable than my hello world from Python was. Because I have all of this commands, I have things in variables, and then you can see, okay, I'm going to call my SP execute external script, what language, and I'm just going to tell it my script, and my script is already stored in a variable here. Rather than trying to do that in line, trying to manage it, it's usually easier to do it this way. Have your script in a variable itself, and refer back to the variable in your stored procedure call. And I have my input underscore data underscore 1. What is the SQL that I'm going to be running? That I'm going to be inputting into my R script. Input underscore data underscore 1 underscore name. Give my data a name, and output data. It's going to come back out in a different name. My input data, so I'm going to run a SQL script. I'm going to run select star from sensors, and it's going to go, the input data 1 name is called SQL data, so it's going to go in this variable called SQL data. How do I know that it's going in here? Because the parameter name. The parameter name is input underscore data underscore 1 underscore name. So I'm specifying the name of the variable that my result set from my query will go into. So it's going to go into SQL data. My output is going to come back as sensor data, a variable in R called sensor data, which is here. My R script, what that's actually going to do is I'm going to store SQL data into sensor data. So I'm going to, what this thing will do is it'll run the SQL script, it will put it into SQL data, run it, store it into sensor data, and then this print summary sensor data is basically going to summarize my table, give me some words, diagnostics on it. So let me show you what this looks like. That script is actually here. This use Sudoku test. There's the R script, the SQL data, the sensor data. You go ahead and run it. Ignore the commented stuff. You don't need to see that. It was just from a previous example.
I think we're still in your slideshow.
Uh-oh. Thank you for the heads up on that. Can it let me run over? There we go. And a lot of some time on processing there. Okay. So this is the very same thing that you saw in the slideshow, where there's the R script, there's the SQL script. Then we're executing said script. Now, what you're seeing down here in the results tab, this is the SQL output. If I go to the messages tab, and I'm going to resize that so you guys can see the messages tab, this summarization is coming from R in this case. So when you're working with either R in SQL Server or Python in SQL Server, if you're doing any prints from R or Python, they appear in the Messages tab. If you're doing any of the queries in SQL Server that return results, they will appear in the Results tab. So just be aware that you're going to be looking in two different sets, typically if you need to look at them separately. Now what we saw with the Python thing, where you had the variables declared in SQL, we changed them in Python and then we did the output, it was in here. Because in SQL Server, their print was coming out here as well. So this is using the summary command in R to take a look at the data and summarize it with what that summary command itself is using.
So can you interpret what that summary means? What does that mean to you? What's 35:39,451?
So, me, I would think that's the number of observations.
And they average to be 35?
No. As in, I think there's 35 observations that have 39,451 as the value.
What of your data would have 5 digits? Oh, is that
Sensor name. Sensor name.
Oh, sensor name.
Sensor name, sensor value, or just sensor value. The formatting looks weird to me, so that's.
I mean, what's the point of having a summary if even you don't know what it means? And you're familiar with it.
I'm familiar with it at a bare level. I don't play with it enough to look at the details.
Okay, so the summary is not necessarily something you would really use for your.
It's just to show that there's an R command called summary.
Oh, that is doing something.
Yeah, something
okay.
more than just print.
Yeah, okay.
Yeah, something more than just print. Just so you can see again that it was just more than a print. We're calling the summary command.
Gotcha.
And I usually have a lot more context because I'm usually playing with one of the R sample data sets. This one doesn't have a lot of context in it. That's why I'm like, that should show you, I think it's the number of observations and what they have in common. It's the summarization thereof.
The 35 is one of the temperatures, so maybe
it
was like 40,000 times 35 showed up.
Yeah, that's my guess on that, is that there were the 39,000, because this is a 400,000 plus observation set. Observation is how many data rows, essentially.
Yeah, so it wouldn't be bizarre that you have 40,000 at one temperature.
No. Actually, it would be.
Kind of a wide range, though.
Well, it is and it isn't. And from the
because some of those are bad sensors?
Well, some may have been bad sensors, and some might have been on our back porch.
Oh, okay, then that makes a lot of sense.
Yeah. What's that?
Oh, I thought it was.
That's supposed to have some of the data points in Celsius. But
36 Celsius is
and
really
then
hot.
also the humidity.
77 is extremely high.
No, but 36 Celsius is
The
about
other thing to keep in mind too is, as it's been setting up, we do have some humidity sensors. That column over there actually belongs with this here, so they should in theory line up. So 1, 2, 3, 1, 2, 3. So temp 5 is 77, and then temp 4 is 71.6. Those I believe are in the house. The humidity sensors live either in the basement or in the sunroom. And right now it's kind of cold in the sunroom because it's not tied into our heating system. So.
And the 471, 677 is at the total.
The 471, 719 is the total.
Okay, there's a 7. There's a 677.
Yeah, so this is doing some of the other dates. There's all sorts of weird other rows. So this is basically each of these timestamps, we're recording 8. And then there are other records with different dates that aren't showing in here. This one here is showing that the common the sensors and their values. So the summary allows us to see how they're grouping and the trending at a high level. I wouldn't rely on it for much more than a truly high level. This is the kind of data you're looking at. Python, similar kind of setup with your SPXQ external script. You can follow, hold on, let me go back to the R for a minute. You can follow this this pattern for Python. You can do the declare a script variable, put your Python script in a variable, declare SQL, store your SQL, and then execute. I'm just showing it 2 different ways so you can see that there are 2 different ways you can actually run this. So I could very well have said, for this, to have a Python script, have a SQL script variable, and then put those variables on here. But basically what I'm doing is, when I'm dealing with Python, I'm using input underscore data underscore 1. Because I'm not telling it the data name, it's going to use this input data set. So if you don't see the input underscore data underscore 1 underscore name, if you don't see the output underscore data underscore 1 underscore name, if you don't see those, if you don't see the underscore names, then it'll use input data set and output data set just by default. If you want control over your variable names, that's where those come into play. So let me show you back on the previous slide. At the bottom here, there are two parameters, the input underscore data underscore 1 underscore name and output underscore data underscore 1 underscore name. Those parameters could be also used in Python. But this is to show you that if you don't use them, input data set is what it will automatically be translated as. Convention for the way this is set up. So I'm going to call select star from sensors, get all my database, all my data, put it into Python, and give me a summary of that as well, using Python's pandas library. Pandas is already included when you install the Python support for SQL Server. Just a heads up, I was looking at tutorials for this. Some tutorials show import pandas, some do not. You do not need to import your pandas in order to use them on Python with Windows for SQL Server, because it's already included, already loaded. Okay, let's talk about some more slides here. So we've got.
Would that summary look different then?
What's that?
With the Python
The
summary?
Python summary is going to look different, yes. And it's just because R and Python do their summaries, they are calculating different things from what I remember seeing. Let me see if I've got the Python summary here. If not, I can pull my slide back up and read. Python Hello World. My Python demo. They're just showing calculations. All of these demos are showing Python for loop. So you can see what Python syntactically looks like. We have an example with employee names and calculations. This is where I was talking about input data set and output data set are being used implicitly. We're not specifying the names. What version of Python? How to read from a CSV using pandas. I don't know that we can. Let's see if this is going to cooperate. All right, let's run it. We'll see what it shows.
While we're waiting for that, just a question. First of all, I know you said that the first time you run it, it's going to take a while.
Mm-hmm.
What's actually happening in the background that's causing that delay?
I think it's a call to machine learning services and machine learning server or the coverage to get that Python support started up.
So is it safe to say that that service is pretty much dormant or stopped until that initial call?
I think it's fine until call. I think it does have a time up.
Okay.
And what I've been playing around with looks like it's got that same behavior consistently.
Okay.
And I notice it's slower with Python than it is with R. I don't know if that means that there's maybe more Python support in there that I just haven't played around with yet.
Mm-hmm.
Alright, so what do we have out? So we should have, this is data set information. A lot of data. And then invalidating sensors. Oh, what should every SQL script have at the top? The correct use, which is used to do the test. Might help if I actually use my databases. There we go. So you can see that it summarizes a little bit differently. It shows that I have 471,725 observations. or rows. And I have 8 unique sensors. I have 1,238 unique different values. Of course, I have 158,645 unique dates, and then unique IDs as well. So you can see, and it summarizes differently. And that all depends on what you're looking to see in terms of Python or R, your familiarity with those as well.
So when you know what you're doing with R,
Yep.
you can really get anything you want.
Yeah. As long as you have those library support, which I've seen basic library support for stuff included with R.
So would you say that you could do it, or somebody who knew R really, really well?
Somebody who knew R really, really well, somebody who uses R in their day-to-day job all the time
Okay.
would be fine. Me doing it on the fly, not so much.
That just tells me how complex R is or isn't. That's why I'm asking.
R isn't really that complex.
But if you just use it here and there, you're not going to get into it in the depth that you possibly could.
Correct. Yeah.
I got a basic question. Is R like Python? I mean, are they two equivalents, or is one a language like Java and the other a specialized tool?
They're
Like
both,
some statistics
they're
back?
both languages of sorts. Python, of course, has been around for quite a while. Science, math, statistics have always been strong points of Python, but you can use it to do other things as well.
All right, so it's a general purpose language with
Right.
emphasis on science and statistics. What about R? I thought R was a statistics tool from day one.
I would say it's more statistics. You're not building. Well, you could probably find a way to build a map because I know we play with R. I would. You could do that. Just because you could doesn't mean you really should. Python is if you were doing like full application kind of stuff.
Yeah.
R is more good for statistics, data analysis. That's what it was built for, with that kind of stuff.
Well,
And
if I forget about R for the minute, and I look at, I could use Python.
Yeah.
So, what about other languages? Are there other languages that have pluses and minuses similar to Python for doing this kind of stuff?
probably
Do they need to be authored by Microsoft
no.
for support? I mean,
And Python and R are not, well, so Python and R are not Microsoft, well,
but did
I have to
they
be careful
have to
about
do plumbing to get R and Python to work with the SQL Server? That sounds like it did.
they had there's some plumbing that they had to do with
Yeah,
that.
okay.
Oh, yeah.
And they don't have any, do they have other languages besides those two?
Those are the two that they started with.
Got it.
The stress on started, because I've heard talk of possibly Julia is another language that they've been looking at. So there's talks. Talks are good, but until we see it, it's all just an update. But it's in the pipeline. And Python is one of those, like if you step out of the SQL realm and just think of the data science languages in general, R and Python are the two key ones.
Thank you. That's what I need.
If you come from a software development background, you're probably more familiar with Python, just because it's been around for quite a while. I've given this presentation with statisticians in my audience. They're more familiar with R. They don't have that Python know-how. So it's a trade-off. There's one easier than the others, and not really. That's a personal kind of thing. Like for me, languages are languages. I found R very easy to pick up, but I also had MATLAB. It was a part of my engineering background, and so a lot of the MATLAB stuff that I remember. I was doing an R, and I'm like, this makes sense. So, question over there?
Yeah, I took, about a couple months ago, I took 2 Pluralsight courses. They're very basic, introduction to machine learning, introduction to data science.
Yeah.
And I don't know when those courses were actually created.
Yeah.
But a big part of what they talked about was massaging the data before you build your models.
Yeah.
And you're assuming this data is already massaged. Because if this were a real data set, it would already been massaged, correct?
Maybe.
Because their big thing was you're going to spend a lot of your time getting your data right. And
Correct.
then running your stuff. And they the example they used was they used R
Mhm.
as an exploratory tool,
Yes.
and then they used Python once they figured out what they wanted to do. But I didn't know, but they did say you're gonna spend a good chunk of your time massaging the data to make it
Yes.
what you want. So
And R, using R to massage data to find your analyses, to find your gaps in your data, is really easy.
they had some IDE, and I can't remember what it was, but it had all these little pretty boxes and graphs and all that stuff.
Oh, yeah, our
Like
studio.
R Studio.
It was probably this guy. Actually, have it written down below too.
So what does it mean massaging your data? Does that mean taking out like the highs and lows and the crazy stuff?
Making sure what they were doing is they would take these ginormous data sets
Yeah.
and they had domain experts, and they would have these people that would come in and say, these are the data sets that we care about, these are the points that we care about.
Mm-hmm.
And
Like,
then,
what's a point? What do you mean by that?
number of an accident and an intersection.
Okay.
And they would have huge data sets, and they would go by states or counties or wherever you want to do it. And then they would somebody would take that data and manipulate it to get rid of all the bad data,
Yeah.
the garbage data. Maybe they take out the outliers, or maybe they rip out all the negative values because you can't have a negative act or something crazy. But they take the data, and they emphasize this. The data had to be cleansed or massaged before they could put it through any of these toolings, because they were doing predictive analysis.
And when they're doing massage, you're probably using something like this.
And see, all they were doing is they were taking the data out
Mm-hmm.
and massaging it and then running and doing something with it, like you said, what they were doing with CSVs.
Yeah.
See, this was interesting because this is the opposite way.
Yeah. You're bringing this
You're bringing
to your data
Yeah,
rather than
they were doing it
exporting
the other way.
CSV.
They never even talked about doing it this way.
That's because this tool, so SQL Server 2016 has been out a little bit longer than SQL Server 2017. But the people who are using this, I think, are using different data sets and aren't necessarily on SQL Server. Now, if they're on SQL Server, this product might not be getting enough
Yeah.
visibility either.
Again, it was very high level.
Yeah. Because this is our studio that I'm showing right now. And this is, what it looks like to massage data. So this is me actually calling out to the MySQL database, which won't work here because it has to work from when I'm at home. But you can see I'm using libraries to talk to the MySQL server. TidyR and dplyr are two common R libraries used for making your data tidy, making it clean, making it, you massage it into manageable data. Also allows you to look at what they call the observations, the rows, to see where do I have nulls, where do I have not availables, names, and how do I get rid of them? Or do I want to replace them with something else? It's very easy to do that in R. Does that help to kind of
These
see
are
the R
libraries?
too?
These are our libraries?
Yeah, so this particular thing that I'm showing right now is our studio.
Okay.
Yeah. And like R MySQL is what I use to talk to my MySQL database. Because usually it's a smaller package I play with. TidyR, dplyr. I took a course, so there's a gentleman, his name is Matthew Renze, R-E-N-Z-E. He's part out of Las Vegas area, part out of Iowa. He splits time at both, but he makes his rounds at various developer conferences talking about R and machine learning. I caught his R workshop, not this Code Mash, but last year, Code Mash 2017. And he actually has a cool storyline about wanting to film a really absurd movie genre, and does it seem legit? And so he's got movie data that he plays with. And this is how I learned about TidyR and dplyr, Looper date. Dates are hard, regardless of what language you're working with. C#, Java, JavaScript, you never have to deal with dates. Dates are a pain. ISO standards that people should actually follow, stuff like that. Standards. But dates are hard. Looper date makes life a lot easier in R. ggplot for plotting. So yeah, you can use R for doing the massaging of data, or you can just bring this stuff right to it. Yeah.
Seems to me that if you're working with SQL Server and R,
Yep.
and you have a lot of R to do, you're going to get in trouble because you won't have the same kind of debugging and flexibility as you're using something like an R Studio.
Yeah, that's a good point. So Rich mentioned that if you have a lot of R code, The downfall to doing what we're showing tonight with running R and SQL Server is you don't have that SQL R debugging stuff.
I was going to ask you about how you debug this stuff. It's just scripts.
Yeah, they're scripts.
Strings, I'm sorry, they're just strings.
Well, they're strings, but yeah, they're strings that there's no format. There's nothing like that. When you're confident enough in your R enough to bring it to SQL, you can. I'm looking to see how you pull the R script itself right into SQL Server, so you can write it in R and then run it. That's on my list of things to make it that much easier, because honestly, if you could write this and then call that into SQL without having to copy and paste it, that's
So that would get you away from moving your data.
Yeah.
But you would prove, you have this thing tested, working, and then you just import it in and run.
Yeah, because you have this for your, like I said, syntax highlighting is kind of helpful to have. You can see I've got comments and strings, and especially when I start to get into this stuff, where I'm saying, okay, take my data and then group it, and then calculate the mean, and then I need to, instead of going this way, move my data so it's going up and down vertically, and then change my date to a certain format, and then I'm changing a column here. And then I'm saying, okay, I don't need these columns, so get rid of them. So this is my massaging data script that you're seeing with the sensors. So I massage it in R, and then deal with it.
So the whole thing with that was all R, that was
What we're seeing here, this is all R.
no, above it, like what you just were showing.
This?
Yeah.
This is all R.
Okay.
And massaging is basically cleaning.
Cleaning it up, making it tidy, making it easy to work with.
Taking out duplicates.
Taking out
That was another
duplicates.
big thing they talked about.
Yeah, taking out duplicates, because duplicate data is usually not a thing you want to do. And like for me, I want to format my data a particular way. Especially
So that tidyr didn't just do any of that? Doesn't have like...
tidyr, so tidyr and dplyr help to provide the access to these, to the group by, to the summarize, to the spread, to the mutate. They also, the dplyr itself allows me to use this, which is basically saying, I'm going to take this, and I'm going to pass it into a pipeline to the next command. I'm going to take my raw data, I'm going to store it in this data variable that's not above. And then with that data, I want to group by it. And then at the end of this group by is another one of these. And so I always put them on separate lines because I never want to actually have to show this code to people. You can do this all on one line. It's kind of gross. Don't do it. You have to talk to people. That's why you use this operator to make sure that, think of it as it's piping. So if you're familiar with command line, and take this command, pipe it to this, pipe it to that, you're chaining that same thing. And so that's what you may see, a mutate, and then I have another one of these at the end of this mutate statement, and then another mutate. So I'm actually changing columns, adding columns, cleaning up columns, and then removing columns.
Is that data on SQL Server, or is it somewhere local and you got to push it all back?
This was in my SQL.
So it's in your database.
It was in a database, yeah.
Okay.
It could be in SQL Server.
No,
It's pulled out.
But it's pulled out, you're massaging, and you got to put it back.
That's,
and then-
that's
well,
all
and the thing
memory
is-
right there. Once she's to that point, it's in memory.
Yeah, and my goal, ideally, is to actually move this into SQL Server demo, so that I'm not doing this here. I'm actually doing it on SQL Server.
Because your data's in.
Because the data is, right, for this particular script, this one was in MySQL, but I could also very well flip it to SQL Server.
But you pulled the data out of MySQL.
Correct.
It's sitting somewhere in memory.
So you did a MySQL query,
Right.
and how did that get stored?
The MySQL query,
Is it just a result?
Yeah.
Normal MySQL result?
yeah, so I actually send a SQL with MySQL query, and I store it in this database using our
Okay, that's
MySQL library.
Now, that's a MySQL command?
No, this is still in R.
Still in R.
This is using our MySQL to get the data. So my goal for the next time I show this talk is to have this in the SQL side, so I don't have to call out to either MySQL or SQL Server.
So I understand that. So R
Yeah.
is doing the MySQL query.
In this case, R is, so I'm using our library called R MySQL.
Yeah, so it's actually doing the MySQL
Yeah,
query.
that's the one that's talking
You have
to
to do it separate.
Correct. But we're in the process of migrating all of our data to SQL Server. And so I can actually show the demo of this, where from library tidyr down, I should be able, in theory, if all the library ported over nicely, I should be able to run this on the SQL Server side as well. Now, whether that actually works or not may be a different story. So if I were to copy this and to paste it in to my SQL Server Manager Studio over here, so sensors. So I could, in theory, paste it into here and run it. I'm not going to touch it right now because demos and support, I don't trust it just yet. But that's my main goal, is to get it to the point where I can trust it. So I can go, look, you no longer have to go to our studio to do your munching, or you don't have to go to Python to do it, put massage data, just do it right here. Again, though, as they were pointing out, as you guys are pointing out, if you need the syntax highlighting, if you're not familiar with the language enough, then it might be more helpful to start in our studio before you put it into SQL Server Manager.
And being able to use MySQL is a plus, because how many databases are really in MySQL? A lot.
There are a lot of smaller ones, yeah. The larger stuff for what we're dealing with nowadays is what's related to the libraries that we show here, and mostly SQL Server or Oracle. Alright, RevoScale R, RevoScale Pi, we'll just talk about this since we're running short on time. So RevoScale R is a library that's written in R, so you guys saw my RStudio, my library, deployer, lots of stuff like that. RevoScale R is another library. Scalable, portable, easily distributable, supports a lot of the statistics things, and regression, linear models, classifying, decision worst. Multi-threaded, multi-node, key. Multi-threaded, multi-node, multi-processor, pass it out. Distribute. Multiple compute contexts. I'm running RevoScale R. It is part of the Microsoft R product. So you do need to install the Microsoft R server for this. And it's also part of the machine learning server. So as you can use any R, IDE, RStudio just happens to be a common one. But you need to have it on the computer with the interpreter and the libraries. I have R and RStudio on here because I've been playing with R for quite a while. Also have it installed in Visual Studio 2017. Visual Studio 2015 has R tools for Visual Studio, RTBS. So if you're in Visual Studio 2015 still want to put our Visual Studio, look RTBS up, that'll get you there. 2017 is part of the installer package, you can select that. Two modalities, you can either run it locally, which I'm doing, or you can run it, shift it to a server or a server farm, shift it to a Windows server, to a Hadoop server, or to Spark. Prediction. These are all supported in RevoScale R. So RevoScale R, this is showing, so this particular screenshot I took out of Visual Studio. So sometimes if you see me with my R stuff, I run RStudio if I want to quick just run R code. I want to actually play within Visual Studio because developer does that to me sometimes. And I can do that as well. There's something called rxgetinfo. So you guys saw a summary in R, and the summarize in Python. Your rxgetinfo will give you more information about your data there. This particular screenshot has to deal with credit scores. I don't believe any personal information data is in that sample data. It is not my sample data. Microsoft releases it as part of their samples for their tutorials. So rest assured, I'm not harvesting your information from any databases. Not it. I didn't do it.
So how do you like RevoScale R?
I haven't played with it enough to have a firm opinion on it. I don't get to play with the large data sets as much as I'd like to. I would say it's worth trying if you're in a spot where you need to deal with SQL Server. A typical workflow for RevoScale R, basically you're going to import and export the data, clean it, so the whole massaging the data, this is that. So you grab your data from whatever data sources you are, put it in whatever the database or the variables for RevoScale are, clean it up, visualize it, which is doing like your graphs, your histograms, making things so that the end user can look at that and go, this is the interpretation of data, now I can make decisions. Making decisions, you can also then predict them. You can also use machine learning to deal with learning, training the models, making predictions that way.
And then there was an arrow on the other diagram in the fluorescent video that basically went from 0 all the way back to the beginning.
Yeah, I was going to say.
They just keep going around and around the circle.
They end up, the presentation that Microsoft uses is, you've got the data source, the compute context, the analytic function, but it's all circular. Yep. Various data sources that are supported in Red Scale R include things like CSV, SAS, SPSS, XDF. If you're doing any ODBC connections to various databases, ODBC talks about lots of things. Teradata, so Dan, your Teradata. And then, of course, SQL Server. Red Scale does that too. What's nice, Microsoft has tutorials in their docs.microsoft.com documentation for Red Scale R and Red Scale Pi. And so you'll get to see something that looks like this. This is off of the tipping from the taxi database, I believe. But these are various functions that they have for graphing, histogram, line plot, the lorem, the rock curve. That's the kind of output that you're going to get in terms of the graphs. That's what the graphs look like generated by them. So you saw my horrible line graph from before. That was generated by ggplot in RStudio. This is the similar kind of quality. Quantile, summary, crosstabs, Q for descriptive statistics. Again, this is Red Scale R. The stuff that you're seeing with Red Scale R support is also for Red Scale Pi, which is the Python library. You can run your R in T-SQL scripts or stored procedures as we showed before, or you can use Red Scale R in R with a SQL context. So various ways of getting your, let's say you've got data on your machine as a dev environment, then you might have a staging environment, and then you have your production, and your production needs to be in a scalable environment. Red Scale R should be able to support your scalability. And then Visual Studio 2017, what's nice is they have Python tools for Visual Studio. They have R tools for Visual Studio, and the SQL Server capabilities within Visual Studio as well. So your developers using Visual Studio, you can just use one IDE with the common tools. R tools, Python tools are now part of the 2017 installer. There are options there, which is nice to see.
They don't have any graphics.
For the R tools for Visual Studio, yeah, they do. They do. Yeah, so it's not just part of the Visual Studio 2017, but Visual Studio 2015, it was RTVS, R tools for Visual Studio. They've gotten better with the support in 2017 and with 2015. So I took 2 courses on Coursera so they have their R specialization, which is like 5 courses long. I made it through the first 2 courses and went through them in Visual Studio for R. Found a little few gotchas where it kept wanting to open Notepad as the editor instead of Visual Studio. They fixed that. It's working. I don't have to use Notepad to edit R stuff anymore. What's nice to this team, if you're working with R tools in Visual Studio and you're like, it has a different behavior in R Studio, can we get that in Visual Studio? Give those people that feedback. They're very responsive to community.
So they will rebuild R Studio and Visual Studio.
Pretty much.
Okay.
I mean, that way you're in just one IDE.
Yeah. Because I didn't know what it was, because I know R Studio, but I didn't know if Visual Studio was as robust as R Studio.
Visual Studio 2015, it was a separate thing. Visual 2017 is something we could build into it. Let me see if it'll start up so I can show you what it looks like. I just started my Visual Studio 2017 with an update last week. No. No, I now have .NET Core supported. Here's what that means. But there's an R tools menu in Visual Studio. There we go. Now I can actually point at it and show you guys. There's an R tools menu in Visual Studio if you install the support for it. And so I can see things like, okay, if I want plot windows, yeah. And then there's that R interactive, which will open down below here, unless I redock it. Thinking about it. And it's saying, oh, you want to demo this? Guess what? That's funny. Come on, Visual Studio. We're friends here. They're friends too. They don't bite. They haven't bit me yet.
It's late.
It's late. It wants to go to the bar. There we go. Oh, yeah. That's what happens when I install Docker tools. That's not what I wanted. They're all.
So, how is RStudio different than Visual Studio? It's just, you're showing us that we can get RStudio in Visual Studio?
No. These are the R language support within Visual Studio.
Okay.
Yeah. And actually, my interactive is over here. Let me see if I can drag that over there too. There we go. Coursera?
Yeah, that's like a plural site?
Yeah.
It's online courses. And the Coursera specialization, the courses themselves you can take for free. It's actually turning in the assignments and getting grades that there's a cost associated with it. Like you can audit them for so much. So I made it to the first two and then I stopped at that second one because there was a peer review. And so I was waiting for somebody else in the class to be able to review my code. And in an online world where you don't know if there's somebody who's actually there, how long you're going to be waiting, I'm like, I'm not going to waste my money and something like that.
So is that used by companies for their training their people? Or
Usually it's
universities?
for people more so who want to.
It's a big, massive.
Yeah.
I thought it was like university classes that you could find.
No, it's not necessarily university classes. They're more like professional development classes if you want to update your skills or get new skills, but they're not to the intensity of a degree. You might, so you can use the term specialization. That means that they have X amount of courses, and at the end you get a certificate that says you completed the specialization.
It could be from college.
Well,
Correct.
if they have grading,
Yeah.
you know, like Pluralsight doesn't have grading.
Yeah,
Yeah, I thought it was a hub.
Coursera does have some grading for some of the courses depending on how the instructor set it up. Like the art courses I took, there are exercises that are auto-graded, and there are exercises that need either peer review or teaching assistant to review it. They have some teaching assistants for it as well. And then the courses that I took were for the art specialization, were developed by a guy out of Johns Hopkins? I always get that wrong. Yeah.
That's interesting.
Roger Ping is the guy who did the courses that I've been taken through.
Can you spell it?
Coursera is COURSERA.
Thanks.
If you do a search for the R specialization, the first course is pure intro to R. What is R? Why would you even need it? Kind of deal.
What's interesting that the guy at Johns Hopkins was using or able to teach statistics and knew it. I mean, that means the medical community must really be into this heavy duty.
Oh, absolutely.
Yeah, because it does predictive analysis.
Yeah.
Clustering and medical insurance is a big one too.
Oh yeah, just medical insurance.
Well, just medical predicting flu outbreaks and stuff like that.
Well, did you know that like Google can predict flu outbreaks before the CDC?
Yeah, because they have all your data too.
I was going to say, it's who's got access to the data and who's got the faster tools and the faster people.
And who is searching for flu medicine at Walmart? Honestly, that's how Google does it.
That's true. Here's some other resources for you guys to look at. Again, the slide deck will be on SlideShare. I'll make sure that the links get into Meetup. Also, Sam can either grab them from Meetup or I can email them to Sam as well. But our services in SQL Server was on Channel 9. It built in 2017 for Python because Python was the new thing in SQL 2017. More Channel 2017. Channel 9 and Build 2017 links. And of course, Microsoft Ignite 2017 talks about the performance patterns in SQL Server. Other places where you can learn more. If you're just getting started with data science stuff, Kaggle. Kaggle is the spot to start because it's got data science, machine learning information, data sources, tutorials, Data Camp is another online site where they learn data science courses. Found my list of things to attack in 2018. Sharpen those skills a bit more. The slide that talks about the different breakdowns of what makes up data science, that comes from this article here from Vincent Granville. Mode Analytics has a great Python tutorial for somebody who just wants to get started. And then, of course, I include links for Coursera to their different specializations. You don't have to go to the specializations. I point to those because there's a collection of courses that are related to that. Sometimes they'll tell you have to take them all at once. Sometimes they say you can pick and choose what courses to take. You don't have to take them in a particular order. So something to look into if that's your cup of tea. Finally, if you need to get a hold of me, I need to update that slide. I am still Sudoku on Twitter. My blog is now Sudoku.com. If you go to codinggeek.com, that will redirect to Sudoku.com, so that's still okay enough. And then, of course, the easiest way to find me, either Twitter or email. My email is Sarah, S-A-R-A-H, at cleatechconsulting.com. Cleveland Consulting LLC. That's me. All me. So any questions you have in terms of that, let me know how I can help. I also will be going out afterwards, so if you have questions, feel free to bring them up to the bar, too. Anything else? Sam, you mentioned something about a slide deck?
Announcements, but first we just want to ask if there's any last minute questions.
Yeah, any last minute questions?
All right, let's give Sarah a big round.